Hello friends. In this video I will explain to you the signals of the ASIC chip on the Antminer S19K Pro hash board. The multimeter is set to the beeping gear. I'll explain and measure its circuit connections as we go along. We can see the signals of the ASIC chip include RST, BI, RO, CLK, and CI. First is the RST signal, which is sent by the control board. Enters through this pin of the I/O interface. It reaches this resistor. Then connects to the RST signal test point. And enters ASIC chip number 1, eventually transmitting to chip 77. The BI signal starts from this resistor. Then enters chip 1, and is subsequently transmitted to the last chip. The CLK signal is generated by the crystal oscillator Y1. First, let's understand the powering to Y1. It's powered by the control board, with the voltage entering through the I/O interface, then reaching this resistor, continuing to the first pin of the level shifter chip U10. The other end of the resistor connects to the third pin of U10. When U10 starts working, the voltage output from the fifth pin reaches this resistor. One end of this resistor connects to the pin 1 of the crystal oscillator, and the other connects to the pin 4 of Y1. Pin 1 is the voltage input pin. Pin 4 is the enable pin. Pin 2 is grounded. And the third pin outputs voltage through this resistor to connect to the CLK. After that, this signal enters the first chip, and similarly transmits to number 77. These two resistors connect to the fourth and fifth pins of U10. The fourth pin is the voltage feedback pin, which connects to pin 5 through these two resistors. At the same time, pin 4 adjusts the output voltage through them. The CI is also sent from the control board, connected through this pin of the I/O interface to the level shifter chip U1. There is a white dot here in U1 indicating pin 1. It is connected from pin 4, and then transmitted from number 1 to number 77. The RO signal is the 1.2 volts of the last domain through this resistor, connected to the RO signal test point here. Then enters number 77, and is transmitted in reverse to chip number 1. Then it connects to the second pin of the level shifter chip U2, and connect to the I/O interface back to the control board through the fourth pin. Additionally, there are 10 such 14-pin chips on this hash board. There are 5 on this side, and 5 on the other side. These are operational amplifier chips used for signal addition. They connect 2 domains. For example, this is the first operational amplifier bridging between the first and second domains. The second one here bridges between the second and third domains, and so on. Their powering comes from the series voltage divider of the domain voltages. Next, let's power the hash board to measure the relevant voltages. We need to use this test fixture and an adjustable PSU to power the hash board. setting the voltage at around 15 volts, and the current at 31 amperes. The output voltage of the RO level shifter chip is about 1.2 volts. The input voltage is around 3.3 volts. CI level conversion chip, its output voltage is also about 1.2 volts. And the input voltage is around 3.3 volts. Then, measure the voltage of the level shifter chip for the crystal oscillator. Its input has around 3.3 volts, which is normal. The output is 1.2 volts, also okay. Continue to measure the input voltage of the crystal oscillator, which is about 1.2 volts. Its output is around 0.6 volts. Now, let's explain the method for measuring the signal voltage of the ASIC chips. The first is the measurement of such cross-domain signals. They are signals bridging between two domains. For example, this set of signals bridges between the second and third domains. When measuring, there are two steps. Step 1. Based on the direction of signal transmission, we need to find out which chip the signal is sent from. From this, we can infer that the RST, BI, CLK, and CI here are sent by this chip, while our O signal is sent by this chip. Step 2. Identify the negative pole of the chip based on the transmission direction of the domain voltage. The domain voltage transmits in this direction, so its negative pole is on this heatsink. The negative pole of other chip is on this one. The normal voltage of the RST signal is around 1.2 volts. BI is a pulse signal and does not need to be measured. If measured with a multimeter, it would show 0 volt. The CLK signal is normally around 0.6 volts. The CI signal has around 1.2 volts. When measuring the RO signal voltage, place the probe on the correct negative pole. Its voltage is about 1.2 volts. Next, we measure another type of non-cross-domain signal. For example, like these, they are relatively simpler, but still divided into two steps. Step 1. Identify which chip is sending the signals based on the transmission direction. The CO, CLK, BO, and RST here are sent by this signal, while RI is sent by this chip. Step 2. Confirm the negative pole of the chip based on the transmission direction of the domain voltage. The domain voltage is transmitted in this direction, so the negative poles of these two chips are these heat sinks. After measuring, we can see their voltages are normal. Finally, let me demonstrate how to measure the voltage of these operational amplifiers. At this point, we can use the adjustable PSU directly, without the test fixture. As mentioned earlier, the operational amplifier is powered by a series divided voltage of domain voltage. Its powering is taken from the voltage of domain 11. This one is powered by the voltage of domain 10. Others can be deduced in turn. To measure their powering, we can measure it at pin 4, which is the powering pin. It is connected to the filter capacitor. For example, this operational amplifier. It is connected to this filter capacitor. During measurement, Place one probe on the corresponding domain's negative pole, and the other on the left end of the capacitor. The same measurement method applies to the others. Okay, that's all for the knowledge related to signals on this hash board. Thank you everyone.